Hello, advanced algebra students, and welcome back to another video lesson as we continue to explore imaginary numbers and look at solutions to quadratics. So I'd like to start out with just a little bit of review from yesterday and our video on the introduction to imaginary numbers. Remember that I, this letter I from Descartes, really represents the square root of -1, which means I squared is equal to -1. And that's the two main parts from yesterday's video and what allows us to simplify. And so I've got three examples here, again, that I just want to talk about simplifying. And so if we look at the first one, 16i over 4i, 16 over 4 is really 4, but an I over an I really eliminates, and so we're left with 4. 6i times 6i, if we were to write that out, imagining that it is a variable, we get 6i squared, but remember that we can replace I squared with -1, meaning 36 times -1 is -36. -36. And then our last one, when we have a negative underneath there, let me just try and illustrate this again. I can rewrite this as the square root of -1 times, let me write that a little more clearly, square root of -1 times the square root of 25. We can rewrite that first one like this, because we know the square root of 1 is now I, and we know the square root of 25 is 5, so we'll just switch the order and say 5i. And so instead of going through that process every time, we just know that we can take out the I and then figure out the square root. In this case, the square root of 144 is 12. And now this is just like a problem we did over here. 5 times 12 is 60. I times I is I squared, but we know I squared is -1. So 60 times -1 would give us -60. And that's really the purpose behind using the I values to, in a sense, be able to try and simplify as best as we can. Now, where we're going today is more about solving and what we've done in previous chapters, in previous lessons on solving. And so, in this first example, our first step is going to be to subtract 5. After we subtract 5, we've got 3x squared equals 15. When we divide by 3, we'll have x squared equals 5. How about you write squared, Mr. G? X squared is 5, so we can take the square root of both. And when we're solving, that's when we want both the positive, negative square root of 5. So it's relatively similar to what we were doing when we only have one variable. However, if you notice here in example 2, we have an x squared and an x, right? We have this ax squared plus bx plus c. We need the equation to equal 0, so 6x squared plus x minus 2 would equal 0. And we had a couple different ways that we solved this in previous chapters. We tried to factor using that box method and finding out, is there a greatest common factor, or what box can I use to, put 6x squared up in the top left, and then the bottom would be the -2, two numbers that multiply to -12 but also add up to 1. And so let me make this box just a little bit larger, because that's a little hard to see, and we can actually use this box method. So factoring. We did 6x squared in the top left box, and then we did -2 down here. So those empty 2 boxes, we need to have them multiply up to be -12x squared. And they have to add up to a 1x, or 1, So they're adding up to 1. Well, what two numbers multiply to negative 12 but add up to 1? 4 with negative 3. So one box would be 4x and the other box would be negative 3x. And then I'm finding the GCF 4 times. The GCF of 4x and negative 2 is 2. The GCF of 6x squared and negative 3x is 3x. The GCF of 6x squared and 4x is 2x. And the GCF of negative 3x and negative 2 is 1, but this is going to be negative because the box closest to it is negative. And so we have those two factors of 3x plus 2 times 2x minus 1 equals 0. And those were our factors. And then we set each factor equal to 0 so that here we would get x equals negative 2/3. And over here, x would equal positive 1/2. Now, that's review from a previous chapter. And the reason we can just use those methods that we did in the past is because our results all came out to be, rational or whole numbers, or even positive, not, real numbers. We don't have anything imaginary. And what we get into now today, though, is looking at what happens if we have imaginary solutions. So let's look at these two examples first. Our goal is to still isolate the x squared part so that x squared equals negative 961. Our next step is to indeed take the square root, and therefore z equals the square root of negative 961. Now, when we were previously doing this, we didn't know how to take the square root of a negative number. It was virtually, I'll say, impossible. And so now we've learned a method that allows us to remove this, not remove it, but replace it with the letter I on the outside times the square root of 961. And the square root of 961 is 31. But now when we are solving, we do have to include the plus minus sign. So plus or minus 31i, where I is telling me that it really was a negative underneath the square root. So that z would equal plus or minus 31i. Similar process here now in number 9. Okay, we're going to move the 49 so that I've got 4x squared equals negative 49. I'm going to divide by 4 to show that x squared equals negative 49/4. I'm not going to simplify that into a decimal because I notice in this next step of taking the square root, I can find that a little bit easier. So x equals, instead of being able to take the square root of a negative, I'm going to put the I on the outside and now look at square root 49 over square root 4, which gives me 7 over 2i, but I'm going to put the plus or minus on the front so that x equals plus or minus 7/2 times I. And again, I can break up a square root into the square root of the top over the square root of the bottom. So square root of 49 is 7, square root of 4 is 2. The I comes from the fact that we were taking the square root of a negative again. So some of these where there is the only variable is x squared, our goal is to still isolate. However, we are going to run into problems, though, where that's not the case. I've got 2, a 6, w, and a 5. So this is where we've got to go back to using this quadratic, the quadratic formula. So let's see what happens if we use that with number 7. The opposite of b, which is negative 6, plus or minus the square root of b squared, so that's 36, minus 4 times a times c, all over twice the a value, which is 2. And so we simplify what's underneath the square root first. -6 plus or minus. This is going to end up being 36 minus 40. So I'm left with the square root of -4 all over 4. Now, when we simplified underneath that square root, we end up with a negative. So what have we been doing the last, yesterday, now, and today? We know that we can replace that. -6 plus or minus. I can take the negative out by making it an I, and then we're left with the square root of 4, which is 2 all over 4. And if we're trying to simplify that, which we should, we're going to write it as -6 over 4 plus or minus 2i over 4, and then we will simplify each part. That's -3/2 plus or minus 1/2 I. -3/2 plus or minus 1i. And it again stems back from the quadratic formula. And then once we get a negative underneath, remembering that we can take out the negative, replacing it with I. So let's look at number 8. Again, the first thing we have to do anytime we're trying to solve is we really got to try and get our equation equal to 0 so that we can solve. And then we're going to plug it into that formula. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over twice a, which is 2 times 1. So now we're going to work on simplifying. 9 plus or minus the square root of 81 plus 88. -4 times +1 times -2 becomes +88 all over 2. Or 9 plus or minus the square root of 169 all over 2. Now notice, it's a positive square root, so I don't need to do anything with an I value here. We know the square root of 169 is 13. So we're going to calculate 9 plus 13 all over 2, and then we're going to calculate 9 minus 13 all over 2. Or we get x could equal 11 or -2. 22 over 2, which is how I got 11. -4 over 2, which is how I got -2. So we won't always be using an I value, but whenever we have that square root of a negative number, like we got here, -4, we have to use the I value to help us to simplify. And eventually, working ahead a little bit, we're going to take and pay close attention to this particular value when we use quadratic formula. Notice, when we had a positive value under there, we got 2 real solutions, 11 and -2. Positive number gave us 2 of them. But when I had a negative square root, we didn't get any real solutions. We got a couple of imaginary solutions. And we're going to pay close attention to that tomorrow. If you have any questions, please make sure that you reach out. Please make sure you're trying the practice problems today. Otherwise, until next time, everyone, stay safe.